Hello, welcome. We are here for a new 4coder Friday. If you want to check out 4coder, you can go to 4coder.net where you can download a binary version from itch. You can hang out with the Discord community if you click down here. You can check out the documentation. You can also go to the 4coder community /4cc public repo. This is the version I am looking at during 4coder Friday, so I'm reading off of what the community has done over the last few years since I open sourced it. And as a reminder, this stream, as well as everything else that I do connected with MrForth.com, is all funded through people like you who see the streams and see the projects and choose to go to MrForth.com/membership and become a supporter or a member. That's the entirety of my income, so if you're watching this and you're enjoying it, just know that in order to keep it going, you might need to become one of the people who does this, and there's also cool perks, so check that out and see if you might like that. We've got the final the third series of graphics programming videos is going to be on the index soon, and then the index will be almost done, so that's exciting. And we do weekly devlogs, which will be interesting now that there's a project going on that's getting heavy development. These will start getting more and more exciting to catch. And there's other cool stuff, so be sure to check that out. It's much appreciated to everyone who's made that decision. And with that, let's get to 4coder Friday. So yes, I forgot to set up Visual Studio. There we go. So what I was looking at, and I just lost it. I think today what I'd like to do is look through just some of the styling stuff happening in 4coder. I noticed in the core, things are a little cleaner than they are in the custom layer, but there's still a lot of problems compared to how I would normally do stuff now. And so what I want to do today is show a couple of examples of how simple style changes in the core could help to make the code more understandable. And along the way, I will then be able to understand some of these data structures that I built and see if they're still up to the if they still make sense given the way I would probably approach them now. So let's start with this one, the text layout system. If I remember correctly, the primary purpose of the text layout system is that we want to store information about lines of text. Item colors, buffer point, buffer layout function. Text layout, free nodes, layout ID, ID counter. Yeah, and so like you can see, I've got some data structure here, but I don't actually, without seeing the mappings between the different data types that are involved, this is actually not enough. To answer the question in the chat, I don't work at RAD anymore. That's true, though. I did work at RAD, but you know, jobs aren't forever. I'm doing this now. What I'm gonna do is I'm gonna put on some non-distracting work music, and I'm gonna start rewriting some of these, not to submit them back to the repo or anything, but just to sort of make it more my current style. So first thing I'm gonna do is my headers contain types and then functions. And that's because I like to have all of these forward declared. So over here, there's, 100 lines of code, and a lot of it's just like blocks of code doing stuff, but I can't tell what functions exist easily. So I'm gonna start with that and make that problem go away. Thread context, thread text layout container. Let's see what we have with all of these. Alloc a layout. Release a layout. We're gonna need some time to figure out what all of these things are about. Dang. Okay. So some things here that are annoying, I have to manually pass the thread context around apparently. What is the thread context helping with? Okay, right. So nowadays I would use a thread local, so this wouldn't have to get passed through. Um, since this is just rewriting to get a main idea of what's going on, I'm gonna just eliminate those because they just are making these look longer than they need to be. Okay. I'd probably rename this to something like text layout. Call this the TL. So we'll do text layout will be TL from now on. Hey, Teralis. Can't tell the difference between L's and I's on the Must be an L. Okay. Well, thank you. Gotcha. So this is just the allocate. So really this could just work like this. It doesn't do anything with the models. Also, all of these things that say text layout, these could just be TL. So this wouldn't need models either because a release doesn't use the models. So this just becomes look up the ID in the container. Release the layout, erase the spot from the table. This seems strange. Why is there... This is part of the customization layer, so that's why it's escaping the usual header organization, I guess. Damn. Ugh, this is so complicated. Figuring this out is actually more complicated than I expected. What is this? What is this thing here? What purpose is it serving? Okay, it's part of the types. Okay. Hmm. Man, I don't really know how this algorithm is working. Let me see if I can map out text layout create is taking in a buffer, a rectangle of F32s, and a so-called buffer point, and it's outputting a layout. And it's doing that by saying well, it's relying on a few things. So we're able to go from the buffer to the layout function. We're able to go from the buffer to the font face. Now there's this thing here, file get line layout, which is working by taking a buffer and a layout function and an X value and a font face and a line number. Now putting a list of layout items. Well, why don't we call that a layout line? Right, and a layout line, we're now going to go look and see layout item list. A layout line contains a list of layout items. A layout line contains height F32. What the heck do those mean? Yeah, so now the layout system, it crosses over into the custom layer. Rough. Okay, so we have a function that takes in, what is this? Layout right. Takes in and modifies a layout line. Font face. Takes index U60, 64. Code point U32. Layout item flags are rect F32 and padded Y1 F32. Takes all of that and sends it to a new value for the layout line, which includes a new layout item. I don't know what the reflex thing is about. These all appear to be passing a reflex through. When do any of them use it? So confusing. Just so we're clear, this is why I think there's a problem with 4coder. I don't think it should be so common to discover things that you really can't even figure out why on earth you did them. And this, because of overloaded functions, I'm not quite sure which function this is calling. There are too many versions of layout, index, xshift. But as far as I can tell, they all just have a reflex parameter that they pass in to another index xshift. I don't see any of them using it. So, like, watch. Since I don't have the functions written down anywhere. Oh, here we go. These are all written down right here. These all talk about taking a reflex. What if we just don't pass the reflex through any of these? What happens? There. That one right there is the one that uses it. Yeah. I think it's called reflex because it wants to be able to read out of its own state. Like it's... We compute a cursor when we want to get the cursor line in position. Then we use the reflex buffer width and face. Okay. And what does this layer do? Get the line number for this position. Get the line layout. Layout box of position. Yeah, there's more of these layout functions over here that are just getting missed because they live in the wrong layer. Okay. So what are these things actually doing? This first one we're dealing with the layout line in the V2 F32 going to S64. This is like index. Let's see. We need consistent naming so that we can actually name things in a way that tells us what they do. So we put in an index and we're trying to get back an item. Now some items might actually subsume multiple indexes. It's the only way to know when that has happened. This is a linear scan over the blocks. So that's not very good. But this is item from index. it takes in a layout line and S64 and outputs a layout item. Rect from index. Easy enough. This is the same thing again. Padded rect from index. Okay. Okay, so that's what this file is providing, is these mappings. So once you have a layout line, it lets you use those things. Now if we go back to the text layout part, I was still confused why I don't know how this gets used. Seems weird that it's related. Okay, from what I can tell, and I'm still just piecing this together here. Here's the lookup. Here's the layout function itself getting called. Okay. This is a point of interest. This one right here is taking all of these and mapping them to a layout line. The layout function itself is applied to a buffer a range of indexes, a font face, and a width parameter. So this is becoming, right, we're doing line number to range S64 to get from there to there. That's moving to that, that's moving to that through this. This moves to there, this moves to there, this so all this function is doing is applying this to these with a certain amount of rearrangement because everything's sloppy. But this is also providing a layer of caching, right? We can see that if we take the face, the width, and the line number, we form a key out of that. We then look up, so there's the buffer can be mapped to, let's call this a layout line cache, right? And so the layout line cache is being fed this key in order to find a layout line. The layout line key is a font face, a width, F32, and a line number. So if we take those three parameters, boom, 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 and boom, they make our keys so we can find layout lines that way. And when the cache doesn't contain the layout line, we can build it and add it to the cache, right? What's different though is that the layout function itself, right, so this is keyed on the buffer because we get the cache from the buffer, not because the cache data structure takes in a buffer. This could just as well have been a global cache that just took these parameters, but I didn't build it that way for some reason. Next programming asks, what are we building today? I'm not actually building anything. I'm critiquing the 4coder code. 4coder is a project I worked on up until a couple years ago. I took a break. The community around 4coder still develops it, so you can go to the 4coder community fork over here at GitHub 4cc. This is the code I'm looking at, and I'm just kind of critiquing and reviewing how all these different things ended up. Okay, so I think, yeah, I think it'd be nice to get the file function, the file indexed properly like this. This is 500 lines of code, so this is a significant one. This is all stuff that's internal to the core. As I do this, it's becoming, it's emerging from the order and naming of things that there's not as much like organization and planning put into this as I would want, for one thing. I can't tell, like, none of the separate paragraphs here have been labeled, so I don't really understand what, if anything, was the significance of grouping things this way. And I also have pretty good reason to think that some of these things probably weren't grouped in any particularly careful way. They just ended up wherever they ended up. Because when you're looking at code all spread out, like it is on the right-hand panel, there's no way to get an idea for the bigger picture properties of the code. So since it's organized this way, I have to assume that the old me wouldn't have had the opportunity, even if I knew how I wanted to organize things, which I didn't. But even if I did, I wouldn't have had the opportunity to organize it better because I didn't even have the right interface to understanding what the organization looked like and what was in need of being organized. Which is what I'm fixing by switching over to my header sets, my stricter header style here. Looks like I started using a function macro instead of an internal macro. That's funny. Okay. So we end up with about 76 lines, 74 lines of function declarations, minus a few gaps here. Let's see. Strange. Okay. Why would I do that? Well, oh man, inconsistency on file name or string termination rule. Okay. So some of it lives in this thing called state, and the rest of it lives outside of that, which is weird. Can never be sure why I would choose all of the separation of types that I do, but like that's just a part of that, right? Like editing file state is just a part of that. The only thing is that I can clear it to 0 right here, which is probably what I was after. But like, why would I want to only clear those things to 0? What about base name? Why is stuff like that not? Right? Like how... Man. Mapping out the structure of 4coder from the root might be interesting. I'm going to try something here. Okay. Yeah, here we go. Alright, I'm going to try to track out everything that comes from... models. There's an app state for resizing. That's so cute. I'm skipping that. Are these hooks? These look like hooks. each with their own signature. Layout. Yeah, the model is kind of just the root data structure. I don't know what else to call it. It's the thing that defines all of the globals in one place, but puts them in a pointer that you can pass around, rather than having them all be unmanaged globals. Paging Turner, I'm just kind of looking through the core code today. My main theme is I'm looking at all the core code and how things are organized. I also dabbled in the custom code because the layout system happened to straddle core and custom pretty heavily. But I'm trying to figure out how to get a handle on what the core architecture of 4coder is, because in the way I build things now, I would never be lost for trying to explain what the core architecture of a program is. I would know exactly where it is. But in 4coder, I didn't really think that way, and I didn't know how to organize code that way. And so I have to dig into it to figure out the core architecture, and that's kind of what I'm trying to find. I'm trying to find ways to improve the styling of the code, or ways to annotate it that would help me understand what I built. I think the more time I've spent on this, the more, it's not that I want to build a replacement for 4coder, but I do want to show how simple it would be if everything, if a certain discipline of organization and planning were applied through the project. I want to show how simple it would be to recreate something like 4coder, um, with a little bit more planning than what 4coder had. This is not to knock how good I did on 4coder. Back in the day, I was learning and I was also researching. I was experimenting. But there's a phase transition that never happened in the 4coder code base that I do now with new stuff, which is to take all the results of experimenting and iterating and actually refine it down into like a single unified vision somehow. And I never did that in 4coder, so I'm just kind of looking at like how big would the task be if someone did want to make a version of 4coder that was not experimental, that was just the 4coder core features implemented with maybe a new design or a new cleaned up interface for certain things, but just in one go, simplify out all the nonsense. What would that look like? I don't know what some of these mean yet, so I need to go and track them down. Okay, some of these are a little lame looking. Let's go and see. So the managed ID set okay, right. Okay, so with those, I can get a much better idea now of what the managed IDs are all about. So there's, given a managed ID set, you can take a pair of strings. The first one is called the group, and the second one is called the name. And you can map that to a managed ID. You can take in your managed ID set and modify it. By declaring a new one. So there's get, there's declare, there's highest ID, with that you only put in the group name and out pops a managed ID. And so if I could see how that's getting used. Looks like that might be getting used for things like the color table. Okay. That makes sense why that exists. Are there other places where we use stuff like that? Nope. So yeah, this is just sitting here letting us implement the color system. Probably overly overly generic, was only used to implement the color table. What else we got going in here that I can't infer meaning from? Dynamic variables. Dynamic workspace. Here it is, dynamic workspace. Okay. So when we create a dynamic workspace, so complicated. Dynamic variable block init. Variable block. So each workspace gets a scope ID from the lifetime allocator. Which lives right there, yeah. Now, do we really have multiple lifetime allocators? Where do we create lifetime allocators? There's one living in the models, which makes me think there's just one everywhere. Yeah, so this is just getting explicitly passed around, but it's making itself a pain in the ass by doing so. Because it's just one of them everywhere. So it could have been treated like a global, like just accessible from anywhere if I had not forced myself to pass everything through explicitly. So when we go to construct the workspace, the fact that we're building it on top of this particular lifetime allocator just means we have one particular lifetime allocator that they all get built on. Scope ID to scope putter table, and then look, the lifetime allocator actually has to find it. So these are all part of a single attached system without good names. really. User type, user back putter. Let's see, when do we actually create some of these? Workspace init. User type, user back putter. I gotta track that down. Dynamic workspace intersected. I see. The type tells us what kind of workspace we have. And the dynamic workspace itself is built to think that it's generic, because I'm annoying. Lifetime allocator keys, right. Okay. Let's do a deep dive into the lifetime allocator, because that's where the most interesting stuff is going to happen here. So, lifetime allocator. Okay, so we have some of the following things. We have a type called a lifetime key, a lifetime object. We have a lifetime key reference. I find it surprising that both the object and the key have dynamic workspaces attached to them. Lifetime allocator. The way the system works is pretty cool, actually. It was one of my favorite things about 4coder, but looking at how it's written, I definitely can see now that it is not the most carefully organized thing, which is going to lead to some problems. That's an interesting question. Paging, turn, or ask. I think I counted about 8,000 or 80,000 lines of code in 4CC, including the generated files. Do you have a gut feeling of how much code reduction would occur with a simpler architecture? That's an interesting question. I'm not very good at that kind of thing, but I think my gut feeling is it could be at least reduced by half. It could be at least as small. It could be as small as 40K easily. Um, I think if you started trying to go smaller than that, you might start pushing yourself to cut corners. But 40K feels easily achievable. Um, 20K or even 10K is also like people do that kind of thing. Like you can get real smart about what lines of code to keep. At a certain point, though, you start maybe running the risk of pushing yourself to count something as the same when it's slightly worse so that you can reduce the number of lines. And I'm not crazy about pushing things to extremes. Like, I don't want to lose features to reduce lines of code. But I would also like to be able to do more than just reduce lines of code, right? It's like, as I'm reducing lines of code, I'd also hope to increase the likelihood of configuration success for new users. I'd like to improve the architecture of the multi-threading so that more stuff can work smoothly without frame rate interruptions. That when it involves, long, like loading a project, for instance, in 4coder requires patience because it does hang for a second usually when it's loading a large project, and that can be fixed with architecture improvements. But I think with the style of architecture improvement I have in mind, you could achieve better likelihood to succeed at configuring on startup, better multi-threaded architecture for background processing, and 40 lines of code, or 40,000 lines of code. That seems like an achievable set of goals to me, to recreate 4coder with a clean architecture that does all that. Okay. Okay. That initializes it. Don't need these. Okay, allocate an object, free an object, reset an object. So this is, it creates, if I give you an array of object pointers, it canonicalizes that array of pointers. What canonicalize means here is any object in that list which is duplicated gets removed, and they get sorted so that if you put the same set in twice, the same array comes out, right? So an array, a set can be represented by multiple different possible arrays because you can have duplicates that are irrelevant, and you can have order changes, permutations of the items that are irrelevant. And this removes those redundant representations of sets by saying, given any representation for a set, we'll map it to the canonical version. That way you can tell if two sets are identical. Then you can take that object pointer array and as input to this function, look up to see if you've already taken that set of objects and created a key for it. So what's happening with these systems, in case it's not clear, is that we have a set of key objects. How do I want to put this? Each lifetime key is related to a particular set of lifetime objects. The lifetime allocator has a set of lifetime objects. Object add key. And anytime you want to, you can take your lifetime allocator and provide it a set of lifetime objects, and you'll come out the other end with a lifetime key. Right? And then, why do these have dynamic workspaces? That's the question. Keys having dynamic workspaces makes perfect sense. Objects having dynamic workspace is a little more confusing. Why not just let it have a key? right here. Okay. I feel like that's not how I would do things now. The fact that I had to do this before, or felt that I should do this, just shows that I was not I was not willing to push the extra step to like make things work correctly all the way through. What should happen here is, since we have a way to represent a single object, a single lifetime object as a particular type of key, right? We can just make the key where the set is a single object and have that one contain the dynamic workspace. Right? Um, let's see. I'm gonna take a 5-minute break. Let's do this. Perfect. All right, be back soon. Oh, I closed the other 4coder, didn't I? That's unfortunate. That had everything on the scratch. Well, that's okay. Dynamic variables. We're still trying to figure out the lifetime allocator. I think... I mean, what would be most useful, it feels like to me, would be to just show you how I would write the lifetime allocator now. Let's give it a namespace. We're going to need an object type. Let's put this all into... Let's see. Alright. So the basic properties here is that each key is equal to a set of objects. Each object is going to need a pointer back to all the keys, so they are kind of this many-to-many relationship. Although the objects undergo alloc release construction, whereas we want to be able to put in a set of objects to get back a single key. So they end up looking like this. Not sure why we have a key next and a previous on the keys here. Yeah, that's not necessary. So the functions here are I'm bored. Okay. Yeah, there's probably a squeaking. I'm trying to think of... It's definitely from the table. So those are chair sounds. That's what it sounds like when I jiggle the table. At the end, there's the squeak. I think the squeak... I think it comes from the computer case. Yeah. That seems most likely, because if I hold the computer case, there's not as much squeaking. I don't know. I wish I could rearrange things a little bit and put the computer case underneath the desk instead of on top of it. That would free up space, and then it could move up and down. The problem is the desk is an up-down desk. And so I would want it to be like on a platform attached underneath the desk, and I haven't found one that fits my case. How do you spell sorcerer? Sorcerer. Mixer ID, I'm exploring some of the core data structures like the lifetime allocator and stuff like that. And I got really bored, so I'm just writing the code. To show how I wish I had built some of these systems. I'm going to answer the question about what the lifetime allocator is in a moment, because it's a cool feature of 4coder that I don't see in a lot. Like, it's a data structure slash memory management strategy that I never see discussed, so I think it might be worth covering what I did there and why I did it. Again. I've talked about it before, but like I said, it seems to be not a thing people are aware of as a possibility, and it's pretty cool, necessary for 4coder stuff. So I'll show you in a minute. Managed scope from buffer. Yeah. Manage scope from view. Dynamic workspace from handle. Yeah. Create a user scope. Easy enough. Destroy user managed scope. Global scope. Manage scope with multiple dependencies. Bad name, bad name. Clear contents. So this raises the question, do I really want to have the scope be a thing that is separate from the keys entirely? So there's get attachment, erase attachment. Managed objects for memory allocation. Buffer markers. Okay. So the main thing you can do here, it seems like, get attachment. How did I use scope get attachment? Scope ID type, async task task pointer, async task wait, scope attachment tokens, token array. Interesting. Do I like that plan? I mean, it appears to be working. How often did I use it? Scope attachment. Looks like I used it a lot. Yeah, there's a lot of these. I think I have to assume that this is actually a successful piece of the system. You provide a scope, an ID for the variable you want, and the type of the variable you want, and it returns the same piece every time. Mixer ID says that they've used this API and never liked how it worked. That makes sense. So maybe I should rethink it after all. Do attachments get erased a lot? These ones do. It looks like the answer is no, they don't get erased a lot. So let's answer that question. I didn't answer earlier. Well, lifetime allocator, what is that for? The main idea here in 4coder is you have these different things that come into existence that have that are tied to like user action. So if I go Control O and I go browse around until I find, you know, like if we go in here and we look at project.4coder, if I hit enter now and I open project.4coder, I create this new buffer, this one here, and it didn't exist before, and at any time I can Control Shift K and kill that, right? And so that has a lifetime that is unique to that buffer, and it can be arbitrary in relationship to the lifetime of other buffers, right? Other buffers might come into existence before that and die after it, or they might come into existence after that and die before it, or they might come into existence before it but die before it dies. You know, they can straddle on either side. There's no limitation to when buffers can be created and destroyed, so there's no limitation to what lifetime. The lifetimes between these things are arbitrary, up to user behavior. And in a situation like that, you run into things like, okay, I want to search, show me all of the uses of the managed scope type. So just like that, I've just created this list. That part was easy. That's just a scan across all the buffers. That happens in the blink of an eye. But then I start trying to iterate through them, right? So I say jump to, and I'm jumping through my list of locations here from the search buffer. And what happens if I modify the helper file here, but I still want the jumps to be correct? Well, in order for that to work, it's not good enough to just parse this every time. What has to happen is markers get placed on this buffer. Markers sit there and pay attention to when editing is happening and stay where they're supposed to stay. So if I put a marker, for instance, on this character right here, when I see this line, and then I modify this line, well, that marker stayed where it's supposed to go. So now I'm not jumping to where the text right here says. I'm jumping to a marker that is associated with that line that was generated when this line was correct, even though it might not be correct anymore. Okay. And markers serve some other purposes. If I have two copies of the same buffer up, say I put my cursor and my mark like this around this function, and then I come over here and I start editing, I want that mark and cursor to stay in the right spot. So again, those are markers. Well, and the point is, once you've put these buffer markers down for the search, that's cool. Manage, let's go to where we were before. So I'm looking through all my managed scopes, and I put buffer markers down to track them. But let's say now I go and kill this buffer over here. So I say, you know what, helper buffer, you can go away. Now all the markers need to be erased. What if I had killed this? My mistake for bumping the mic. What if I had killed this buffer over here? Well, then all of the, and watch, if I try to go back up to helper, I'm hitting the button that would let me skip there. I can also do it on this one. If I kill this one, now if I go through these, that works, that works, that works. And we skip over that because that buffer, those markers are just gone now. They don't exist. And the way that's happening is that the lifetime of some data is dependent on the lifetime of multiple of those buffers, right? So I have a search buffer and I have just regular old file buffers everywhere. And if both of those buffers have separate lifetimes, then the markers that I attach to those positions want to have a lifetime that exists sort of in the intersection of those two different buffers, right? So to draw this out in Scratch, I have, let's say I've got 4coder helper.h. We have the lifetime of this. And we have the lifetime of the search buffer. And if we were to sort of paint both of these onto a timeline, they might look like this. Right? And then there's the lifetime of the markers between that were generated by this buffer that are attached onto this buffer. And so those markers should have that lifetime, even though there's no specific entity besides the markers that exist, right? This is a buffer, this is a buffer. We know when those get created and destroyed. But how do we know when this gets destroyed to destroy the markers? Or if we were to flip it around, what if this lasted longer and this got destroyed? How would we know to destroy the markers? Right? One way or the other, these need to get destroyed when either of them is destroyed. And so what we have is we have this idea that the lifetime of the marker is the intersection of the lifetime of 4coder helper.h and the lifetime of the search buffer. And that's what the lifetime allocator is all about. You create lifetime objects. Whenever you want to. You allocate them and release them. And then if you want to, you can create a key. And you create keys by putting in sets of objects. You can put in no objects at all, and you'll get a special global key, a special key that is the unique one with no dependencies, that is always in existence. You can put in one object, and then you get a key which stands for the lifetime of the object itself. And you can put in multiple objects, like two buffer, the lifetime object pulled from two buffers. And then you can say, okay, intersect those by putting them both into this function, and out pops a key whose scope will only exist for the intersection of these two things, wherever that happens to be. Additionally, not only is the lifetime itself the correct length of time, it's also keyed by these two objects. So if I ever want to check again, hey, what do we have for these two objects together, I can just put them together again and get back the same key. So that's the other thing it does that's useful, is it gives you a sort of set-based keying logic. Now, once you have one of these things, what you want to be able to do is not just say, okay, we know about the lifetime, but you want to be able to attach your stuff to it. And so that's what the scope's job is. The scope's job is to give you something where you can attach allocations that'll be managed by that scope. And the problem is, or at least the feedback I got from Mixer, is that this API is confusing. I don't know which part, if it's the attachment stuff, if it's the lifetime stuff. I know the one in 4coder, the naming scheme was real bad and confusing. So part of what I'm trying to do here is suggest an alternative naming scheme. You know, I'll also say I continue to be surprised that everyone finds it so confusing, because to me it was the only natural solution to a otherwise confusing problem. I continue to wonder why it's more confusing to everyone else than it is to me. Yeah, there might be something confusing about the idea of having these two buffers and like a data structure that is dependent on both of them simultaneously. That is naturally confusing and hard to describe. The problem might just be hard to describe. It might also be hard to comprehend why that's a problem until you sit down and try to write one. But basically, this is like a garbage collector, but instead of it tracking reference counting or something like that, it's just you create these lifetime objects by saying alloc and release whenever it's appropriate, and then you create dependencies on them. In fact, maybe I could rename these to make it less confusing. I could call these dependencies instead of keys. The scope is like a manager. The hard part is figuring out. It's true, the part I'm less clear on is what the scope should be. The scope could just be an arena, but then the problem is that just because I've managed the lifetime all in one place here conceptually doesn't mean that everything I want to do is going to work that way. Yeah, the naming scheme in 4coder is bad. There's a lot of confusing stuff. There's also, because of the fact that these get used with markers, you get when you allocate markers on a buffer, you get back a managed object. And the whole point of the managed object the whole point of the managed object is that it's like a handle to some, yeah, here it is right here. Each managed object has an item size and an item count, which when you multiply together gives you the total size of it as a buffer. Why it's set up that way, I'm not entirely sure. I can't remember why I would want that. And when you do managed object get pointer, what is this? Managed object pointer and workspace. Workspace, managed object standard header. So why on earth do we allow you to get the header as a void pointer? That doesn't make a lot of sense. Yeah, so that's just a standard header returned as a void pointer. Oh wait, get dynamic object memory pointer. Yeah. Yeah, the style on this could I do think a lot of this might just be easier if I had written slightly cleaner APIs and organized things cleanly along the way. A lot of rushed stuff that never got. I didn't really understand how to present working code in a way that was easy to maintain and understand over the long haul. But yeah, the goal here is to take in that header pointer and return the actual pointer the user would want. I don't think you need any of that. There might be... MixReady says, one thing I find a bit confusing in the example you did before is that I would still expect the search result to be browsable if I close the buffers. So let's talk about that, because I understand what you're saying, I think. So here I can search through my results. When I first hit enter for the first time, it generates all those markers. That's why the lines are now highlighted, and it's why I can jump to these. And if I were to go over here and modify this file and save it, now, when I jump through, I'm still landing on the correct lines. Now, the point is, if I close this and I still go through, I still generate jumps. I still have jumps to everything else, but these jumps in the middle here have been invalidated because the file is closed. If I go here and press enter, nothing happens. If I open up custom API constructor, let's see, where is this? Again, and I were to jump to the line specified 648, you'll see I'm not actually seeing the managed scope anymore, right? I'd have to go 1, 2, 3, 4, 5, and then I would see a managed scope where I could go 1, 2, 3, 4, 6, 7, right? It's just like the lines are now off. And so even if I did want to browse this, it's now wrong because when I close the file, I stopped tracking the markers. So, and there's no way to avoid that part. Like, there's just no solution to... The only way you would be able to do that is if you kept the markers around some other way. Like, you knew they referenced the file. The markers know which file they referenced, and they know what position they were at when the file closed. And when the file opens, they somehow validate that the file is still the same as it was, but when it closed, and so they're still good. But like, the hard thing about all of these is these generate positions. If you wanted a search result list that stayed correct, you'd have to keep computing the search results, because the file, sure, you could use the list to reopen the file. I think that might have even used to be a feature, and I think the reason that doesn't exist is because of what I'm talking about, because of the fact that there's no way to know if the file wasn't open for a period of time, And there's no way to know that the search results actually match to the locations perfectly. Yeah, and yeah, I get that I'm a little bit picky about this. I get annoyed when the search results are off enough to the point that I don't want that, and I probably designed away from it. Being able to do convenient things like opening the file that you're clicking on. Just because I wanted it to only jump to accurate locations. I found it annoying when it didn't. And then if I was sitting here and it was like not doing what I want, then I could just come over here, rerun the search, and now it's working again, right? Part of what's funny here is that like I'm using the buffers to construct more advanced interfaces, right? So the fact is I didn't build a separate search results. I just constructed a buffer and then used that as the data structure for the search results, which has a bunch of limitations. It can't update itself to be accurate. It can't deal with the file getting reloaded. Lots of issues like that. If I did want to make a better search results, though, I don't know what I would do, because if the file gets closed, say the search results were constantly recomputing every frame, for instance. If that was, suppose there was no performance problem with that, maybe there's some caching, so it's recomputed only when a file is dirty or whatever. But the search results stay accurate over here. And then I say I close this. Well, now, by definition, if it's continually updating the search results, it would say, oh, this doesn't exist. It doesn't belong in the list anymore, right? The idea that that was in the list in the first place was because it was reflecting what existed when the search occurred. If it were going to be a data structure that represented ongoing tracking of those locations over time, then it would be correct for it to lose those locations, right? I'm not saying, I'm just saying that like I don't really get what the design of something like this would be that wouldn't be kind of quirky in one way or another. Like if you wanted it to search unopened files and mark which files you could open to get more results, you could do that too. It'd be kind of a grep-like feature at that point. Maybe something like this would work. Yeah, I'm thinking like a grep style search would be cool, and the fact that 4coder doesn't really concern itself with that kind of thing, and that might be a pretty big limitation of 4coder that could be addressed. Mixer ID, I agree. I think you're right. I think it used to be, before markers existed, there was a version of all this that would not just respond the first time you press enter, but anytime you press enter on a read-only buffer, it would check the line for a jump and possibly open the file. And that does appear to have been removed when I switched to the buffer marker system and the scopes and all that. So in this world, I think each scope would have to have its own heap. Built on its own arena. Clearing the scope would be a matter of zeroing out all of the variables and resetting the arena. Now the big difference between the attachment system and the managed object system is the managed object system lets you, say, allocate managed object. There must be a way to free a managed object. I'm almost certain of it. Pointer. Get managed object type. Get containing scope. Free. Right. Maria, I think we're doing pretty good here. How are you? Welcome to the stream. Let's see. So if I go back over to the dynamic variables bit where we were talking about the managed objects in the first place, the buffer markers are the interesting part. Okay, this right here is definitely overcomplicated. Let me track that part down. Take a look at what's happening there. Why did I do item size and count? next and previous. So the workspace gets the list of buffers, the marker list. How does the buffer, let's go look at what the buffer does about the manage buffer marker. I feel like this must show up somewhere where markers edit. Here it is. So it has to scan through the workspace looking for buffer ID matches. Yeah, I believe size and count was for the markers. I just don't know why I would bother doing that, though. Like, I get that it does something when you create an array of markers. It's going to report to you the number of markers and the size of a marker. But why? Why bother? Like, what was important about doing it that way? I don't know if I get that, so... This could have been done by making a more sophisticated data structure to relate the files to the well, okay, so go over to the edit. How do these get called? Read workspace markers. It starts with the dynamic workspace that's on the file's lifetime object itself, which we would eliminate. We would get it through the singleton key, but that's fine. Cursor count. Right. Edit, fix markers, read workspace markers. So this is all a part of the edit, fix markers, read workspace markers. This happens. Right workspace markers. I think that this must be happening after the fact, right? Cursor with index. We go through all of the rights. So we're reading off the markers from these when they're appropriate. So it's okay. There's no comments because why not? Why would there be? But it looks like what we're doing here is scan once. All the views and write out the cursors and markers from the views. Scan once all of the workspaces that are dependent. So the one on the lifetime object itself, plus we look at that lifetime object and we look at all of the dependencies, and each of them has a workspace, and each of those we scan for any buffer markers living there. So a better implementation would have been to have a pointer, a chain of pointers developed inside of constructed inside of the buffer itself, pointing out to all the workspaces or all the managed, all the markers, which may be from different workspaces, and then have those also take pointers back. Okay. So next in previous. I don't see any reason why I need item size and count. Now it looks like it wanted to be able to do things like attaching markers. So there would be basic. I'll just call them marker and arena. We won't need that. But we will need marker count. What would be the thing you'd want, like a pointer out to the watcher? Later, Mixer. API implementation. How did we deal with markers again? Did we allocate markers? Markers. Buffer marker, alloc buffer markers on objects. So we would allocate with a certain count right up front. So I'm thinking something like this is pretty much all you needed from all of this. Like this does define what we're talking about here. All the stuff about having object types is unnecessary. You can just Lego brick it, make every object have an array of markers and an arena. If you want to attach an array that is not markers, I guess this doesn't solve that problem. And so if I wanted to, I could say, hey, in addition to having markers, so there's the arena attached to each object, there's the markers attached to each object. Maybe I also just want an object to be able to say it's got data, right? I mean, why not? Right? So that's sort of like what the point of this scope thing here has been. All of that, all of that. This is just for creating IDs. Dynamic variable block. What is this part being used for? I guess each quote-unquote dynamic workspace has one of these. Yeah, so that's just a part of this, which is the thing we're calling a scope now. This is just global. Okay, okay. So let's see, what else exists in the 4coder core? So the file and edit things are interesting. These kind of correspond to what you would actually call a buffer. So many of the names in the code don't match the lingo in like the API documentation, which is a big mistake. So for instance, this wouldn't be called file, it'd be called buffer. I do believe there's also a buffer.h&c, which implement the low-level part. And so the separation between all these things is annoying. So let's take a look at this one too. This is a good example of what I'm talking about. Right, there's all these functions here that are part of implementing buffer. Some of them are namespace, some of them aren't. Some of it's a little bit sorted, some of it's not. And all of this is just a sub portion of the implementation used for the file type. Okay, there's a separator. There is buffer in it. Place range. Another separator. get chunks. Chunks clamp. Stringify. EOL convert out. Measure starts. Get line index. Push line move. Why that's not marked, I don't know. Count lines. So many of these things. Like, what are these? Why are these all here? Fill line starts. Buffer remeasure starts. Get position range from line number. Get first position from line number. Buffer get last position from line number. Okay. Cursor from position. Cursor from line number. Invert edit shift. Invert batch. So much. So much. Get chunk position. Buffer chunk position. Iterate. There we go. Okay, so that's so many functions. Probably a lot that I don't actually need. Okay. There's all the buffer functions. So let's go through those again. No, get out of here. Cursor with index, positions, count, position. What is that? Right cursor with index. Okay, this is creating the... This is a helper for other stuff. Quicksort cursors. This is a part of implementing markers. Buffer sort cursors, quicksort cursors. Yeah, that's the wrapper on the recursive. Unsort cursors is actually just a sort that is using the positions we originally wrote into the indexes instead of the positions to rearrange things back to their original position. Update cursor lean L. Goes through the sorted positions. Goes through a batch. And updates the positions found in each of those sorted positions based on the batch of edits. So we're pushing these things called line moves onto the scratch arena. At the end, presumably, we have all these moves queued up, and we iterate them and apply some remeasure starts. Well, let me look at when these kinds of things get used. So get chunks is getting used for seek string, seek character class, and find all matches. And that's because those want to be implemented without having to read a copy of the buffer, but just directly access the buffer chunks. Okay, so I think some of that would be worth saving, but we could definitely simplify a lot. So let's see, we don't know. All that is some extra complexity of the implementation that I don't want to pay too much attention to right now. What I want to do instead is look at what happened in the file type, because these were kind of like, this was the low-level data structure part, and then there's like all of this, right? So the editing file contains a state, and that only gets contained in one place, and that's in the editing file. And the state contains a gap buffer. So like this gap buffer is just part of the whole thing. There's also a history. So how did we define that? That's got its own, yeah, of course it does. Okay. So a history is going to be like this. There's this thing, the record lookup. Now each record, it knows its restore point presumably on this arena. Position before edit. That's for restoring cursor positions, which is always a little dubious. So ignore that for now. That's a tricky part. Sloppy, hard to get right. Edit number is worthwhile. Record kind. Where is that defined? That's probably living over here in the global scope or something. Single group. Okay, why did we have a single and a group type? I think it's because I want to be able to group them together and apply them as batches or something. Okay. Forward text, backward text, position. Next prev. First child, last child. Child count. Those. Don't need this. Skipping this for now. So restore point. Why would I use a restore point? The restore point would tell me. So the way the history system is going to work is I've got an arena apparently that is, whenever I write a new record, I'm going to remember how to restore to before that record was applied so that I can erase all that history. These up here all exist because I want to be able to create groups of history records and I'll let them be applied at once. It's useful for whenever an edit occurs, like whenever a command applies multiple edits, so that the undos can look the same. But of course, another way I could implement that is by just creating a chain of edits, right? Then they don't need to be children. Later, Maria. Thanks for dropping by. So then, anything with one edit, we'll just put one thing in this list. And when we want to combine two history records, we'll do so by just combining their chains and making one history record out of them. Now, this is still assuming a linear history. There's one history, and we chop them off, and it's assuming that right here when it creates this array of them. A more sophisticated history system might involve keeping multiple histories and letting each buffer basically be a tree of history. And then you had the ability to restore any of the states. Right? Essentially, instead of a history, you'd have a state ID, so that each state the buffer had been in is associated with an ID. That would be a redesign from what I have, though. I think this is the right thing. If I'm just going to clone 4coder, then linear history, this is a fine implementation for it. Should do the same thing as the one I already have. Now, if I give the history its own arena, then the other thing I can do is say that I'll put a restore point on each of my history records, so that if I want to chop that short, I can. That gives me a way to free lots of these edits and the forward text, backward text that go with them, and the history records, just by plopping them all off the arena. Yeah, this isn't quite complete, but I think something like this is about the right idea. Something like that. Not entirely sure. So there's history. Now if we go back to file, the state has a buffer, it has a history, current record index. Right, we also want a record current index. So you have this linear history, but you can be halfway back, right? You can make some edits and then undo, redo, right? Like the redo does work, is my point. Although the position is garbage. I don't know why it's so bad. 4coder, I'm not building 4coder anymore, but the community is. 4coder community /4cc has been getting little updates ever since I stopped working on it. And now I'm doing a sort of code review, a large-scale code base critique, and seeing how I would do things differently. What I'm driving towards here is I wrote the buffer system in so many tiny little segments, and I never did the appropriate thing of kind of combining it all together. No, 4coder is definitely not complete. Thank you, BYP, for give the right answer on that one. Dirty state. Okay, so dirty state is going to live over in types, I imagine. So this is fine. This is not the way I would actually want to do things in a new system. The dirty flags are a little off, because what I never did a good job of that does belong in probably an editor like this is the buffer is a container of local text information and its history and accelerators associated with it and so on, lifetime objects. The assumption that the buffer data structures are going to have things like their dirty state built right into them is a little off, because dirty state is a relationship between a buffer and a file on the disk. Now, 90% of buffers that you deal with have that relationship, and so building information about that relationship into the buffer makes some sense, because if 90% of your buffers do have a one-to-one relationship with something on the disk, it simplifies how you code up that relationship. But it leads to problems once in a while, having the assumption that all buffers could have this property. Buffers generated by compilation or by search, or buffers which you might want to be able to use a text editor to edit do not correspond to text files because they are related to transient entity states of another application, or they are sort of, coming in over a network, for instance. You can imagine a world where you're using your text editor to modify the dialogue of characters in your game engine, and you don't want a my character dot scenario dot dialogue or dot txt for every single dialogue. You might instead want to be able to browse that as a data structure that's more database like, or like some kind of entity hierarchy, and then select the thing you're editing as a piece of text and still have your text editor be useful for that. And none of those things involve the source of the file, the source of the buffer being a text code, a file, right? And so having the relationship to a text file be built into the buffer is a bit of that naivety of like, what is a text editor really for? What could it be for, that I did not succeed at outgrowing in time for 4coder. But again, I'm not talking about redesigning the capabilities of 4coder, just reinstantiating its capabilities in cleaner code. That's all I'm studying. Save state. File, save state. Saved, waiting for notification. Normal. When does this get used? Save state. Saved, waiting for notification. Just changed file. This is some kind of hack. Save to file name, save state, clear dirty flags, saved waiting for notification. Okay, I think saved waiting for notification means we saved the file and we are expecting a file change notification from the disk, and that file change notification should actually be interpreted as getting us back into sync, because when we go to do save file, we have no way of knowing when we notice that the file changed, because when any application, including ourselves, changes the file on disk, we get a notification. And we don't have in that notification a thing that says, hey, actually, you are responsible for this, so you're good, or anything like that. We just get the notification. So we save it on the buffer. And that's kind of lame. You'd like it if you could do like save a file and get back an atom that says, hey, here's the unique file change atom for this save. And when you get a notification, this atom will come with it. So you'll be able to see that the last atom, the last save atom you got back from a file save matches the one coming from the notification. But we don't have that. We just have this bit. I'm glad that 4coder is useful to you. I also use it anytime I am doing programming, which is close to every day too. You know, besides those like necessary life breaks that come up. Whenever I'm programming, I'm on 4coder. So I'm glad to know other people are getting the same thing out of it. I'll just make that a Boolean instead of a enum because I don't see any other states here. Back to the edit or the file H stuff. So there's the save, the file syncing, built-in file syncing status. This seems strange to me. Do I really use this? I use this when I create a view. File edit position pop. View set file. I don't like that at all. I don't remember liking that system. I am not going to keep that in my analysis here. I believe what this is about is if I were to, for instance, come over here and go to file.h, you'll notice it opened up the same position. If I were to come over here and edit, and then come over here and edit, and then leave this, and then come back, it would restore the old position of this file using that stack position thing. But this was always kind of off. Picking the right position for the cursor and the view when you open a file, when you open a buffer, when that buffer can be opened in multiple views, is just a bit strange. And I think that if I didn't have some crappy thing built in to the core, I'd probably build a better solution in the custom layer, or other people would build better solutions, more interesting solutions in the custom layer. So I'm just not even going to bother with reconstructing some of that stuff. Attached child process. Again, this is one of those things besides a source file that can be cached layouts. And so, okay, so the layout system also wants to be able to have its own arena. So this is significant. I think it lives more like up here. Maybe even more like up here. We want to be able to say line table out. So this matches line layout table. Give me an example of that getting used, please. Key data. Right, so this comes down to how the layout system works. Oh yeah, that's a good point. So if I were going to improve the right, BYP is pointing out another annoying thing with 4coder. Let me show you. If I start editing, edit, and then I undo, it doesn't know that like I've undone back to the point where my file's not dirty anymore. And so a good solution to that would be that instead of making this a state that you track like this, the internal state of the buffer wouldn't be, hey, mark this with a flag that it's dirty. It'd say something like last saved record index synced with file or something like that. I'm not sure. Something like that. Yeah, and then you need this. And so the flags become a part of the interface, maybe, or maybe you can even eliminate the flags and just store this. So that's the line, get line layout. You put in the file with face. The cache itself is mapping these keys to U64s that are actually pointers. And the layout item list lives on that layout arena. Okay, so the layout cache needs to be some kind of data structure like this, probably. Layout cache. Now the keys on these things are well, there's a question if I would even want to attach this on the buffer. Because another way this could be done is to say that layout caching is just a core of the engine, not a feature attached to a buffer object. And that might be more appropriate for a lot of reasons. Then what you would do is you'd use your buffer ID and you'd use the buffer ID, the face ID, the width of the layout space, and the line number as the key to a cache. A hash cache type situation. Yeah, I'm going to say layouts shouldn't be contained within the relevant buffers. They should be, that should be an external data structure entirely. Its own global data structure. It's sort of a accelerator to layouts everywhere. Right. Okay. So that's the layout stuff in the file state. Now we go to the editing file, not the state part. Get the rest of what's happening here. Touch node, external mod node, ID. So we need to know Each one gets its own lifetime object, so that's life obj lifetime object. So we know our buffer ID. Now what are these, Editing file next, main chain node. Don't know what those do. Main chain node, what are you about? My way of handling linked lists used to be a lot more complicated. I'd do all these like node member things, cast from member, main chain node, global set font, and update files. New global face for each working. Okay, in the working set, active file sentinel next. Active file node does not equal file. Cast from member. So we grab that from the main chain. Set the face ID, global face ID. Nice, we found a dead function. And if I check that again, are there other places where main chain node is still relevant? File change notification thread main. Yes, so this is the main loop figuring out when files are changing. File change notification check on that file. So this is just how we track, how we loop through all the main files. Okay, when it says canon name, what it actually means is source file name. Now the touch node, what is that used for? Next. Okay, that makes sense. An external mod node, I assume this gets pushed onto this list here. So this is just a ways of keeping several lists of these things. Okay, so we're just not going to do that. Instead, we're going to say that it's actually important to have like a buffer reference node type. That can move around, and the working set that creates different lists will use those to create those lists. Okay, close. That's still not everything that's in here. That's those different lists. There's the ID. There's the settings, which I haven't gotten to. Now, all of this is basically settings are things attached to a buffer, determining stuff about how it should work. It doesn't have anything to do with the state of the contents. It doesn't have anything to do with the accelerators attached to that. It doesn't have anything to do with the historical state of the contents. It doesn't have anything to do. It's syncing up with its source or its identity within the system. Settings are how determine how certain things should behave, like how we should lay out the buffer and present it, if it should use DOS line endings, etc., etc. And so I guess there's a question here of, do I want those coupled into a core buffer? State. I feel like read only. Unkillable and never kill seem like a redundant pair. So the difference is one of them's core. Never kill gets set by this when it creates the core buffers. Yeah, that makes sense. It's a little unclear. Having those settings built right into the core, like the layout thing is now, it's now a matter of like, do you want to have all instances of this buffer and its content use the same layout stuff? So I think anything which deals with updates to the content, what is initialized for? It's for nothing. Okay. Unimportant marks anything that we don't care if it's been changed. That has to do with more with the syncing aspect of things, which I already think is busted. But read-only and unkillable might be good settings. Like these three might be worthwhile to keep at the level of the buffer. Okay, so that pretty much combines everything that lived here and here into a new buffer definition. And then there's all of these file or functions which are doing all kinds of work. and aren't sorted. There's also, if we go over to buffer.cpp, there's all of these, or buffer.h, there's all of these functions that are doing something that are not sorted, and so on and so on. So like, you can start to see again, 4coder makes it hard to keep track of what exactly exists within itself and what we want to do with it. But a new version would do something like, we definitely want to be able to init buffers. Let's see. Create from strings, definition, call, declaration. So it's only getting used in file create from string, which takes in the value. Well, we didn't look at file attributes. When we were looking at file.h, one of the things it has is file attributes. Which lives right here. So that's mostly there to get us the last write time, I assume. Maybe also the size of the file on disk. That's more of this built-in source syncing stuff. I really don't want to have to keep recreating that. I feel like there would be a drive to get off of that, probably. So ignore that. But you can see how there's like file create from string is the real constructor for one of these things, and the buffer init is a sub piece that never got folded in fully. But yeah, this gets used. So what we're really looking at there is something like well, interesting. So file create from string still takes in the file to be created there. Does someone else give you the editing file from in the first place? Is that like the workspace, the working set does that? Oh, I don't have the functions pulled out for this yet. Here we go. More to do. Working set types. Functions. Okay. Suit yourself. Be about that if you want. Allocate file. There's something where we actually allocate a file. And free a file. Get a file from an ID. Here we initialize the working set. Man, this code is so strangely organized. Contains, add, and remove generic. Probably go with contain, add, and remove of each of these. There's so many layers here. Like there's the working set file, there's the file, there's the buffer file, there's the edit file, the history file. They all go together, but they're all spread out and disagreeing on what actually constitutes the responsibility of the other layers. Okay, so here we finally figure out how a file gets allocated. That's been organized away from the spot where we initialize the file, which is super unfortunate, I think, right? Okay, working set and lifetime allocator will both be globals, so that's not relevant. File.h says that when we init a file, it's actually file create from string. We're gonna go with this buffer new why does this want to avoid just modifying the buffer after it's been created empty? Because we want to call the begin buffer hook after we've set the contents of the buffer for the first time. That's why. Val, that's the part I'm interested in. lot of problems here, like passing down scratch because the thing doesn't want to get its own scratch. Yeah, there should not be an arena scratch right there. That's not good. Yeah, so I think we want to be able to say creating a buffer. We want it to be able to be orthogonal, but we don't want to be able to miss. Something like a begin hook either. So maybe we want to be able to say when we create a new buffer, we'll pass in some parameter block that'll let us do things like low level. You know, this is going to be the low level API anyways, so let's just do that and say that there's got to be a higher level that wraps together things like hooks happening at the right time and stuff. Buffer new will be responsible for things like initializing all of this, setting out IDs and names. This will not be a part of its responsibility, so that this gets moved out. Lifetime objects will be responsible for that. Initializing history, right. So this would be like, there we go. Models allocator and buffer init val blah blah. So that's the low level buffer. Measure starts, history init. Line layout table is initialized. What about the names and stuff though? This looks like it doesn't set up any of the files names. File create from create from string. When do you get called? This is the reopen. Okay, funny function. Let's look at other cases that are not as funny. Right, here we allocate a file, we bind its name. This is during init, right? Here we're binding the name. It's like all that name binding stuff kind of is outside of the lowest level API. Man, there's just no edit, create file, file name. What is create file for? Create buffer, file name. It's the implementation of create buffer. See, this is just not ideal. So yeah, here we're implementing the logic of a rather high-level idea. See if we already have something with this canonical name. Try to get it by buffer name. It's an empty buffer and it has a canonical name. If it's not a never new, create. I mean, this is so system load attributes and heap mem buffer does not equal 0. Yeah, it's so complicated. Allocate a file, bind the file name. Bind the base name. Initialize the contents. So I think what we're saying here is we created an empty buffer, and we can do things with a buffer such as creating a binding to another, to an external file. That's something I would probably want to have work differently. Setting its name. Here we want that nice, simple. Now, why does that come with a shift amount? Shouldn't that always just be text minus the size of the range? Yeah, I don't know. It's weird. I also don't know why edit's the thing that contains the create file function. It's weird. It doesn't really belong anywhere, but certainly not an edit. Anyways. Set this text. Okay, let's just look through the features here. We want to be able to say those will always be on buffer. History enable. That will assign a buffer ID, create a lifetime object. That will set its base name and its unique name. right? Yeah, okay. I think that this is enough for the 4coder Friday today. Essentially, what we've done is we've started the next step of 4coder Friday, which is going to be to pull out a bunch of these key ideas from the core and sort of sketch up a idea of what it would look like to re-implement them. Buffer is clearly not finished, but these other headers are looking good, and they give an idea of what the 4coder core might be like if it had been done very organized and simply. And I think it might be fun next time to look into these issues of the source of a buffer and how I would actually want to change that a little bit. Um, let's see. Popping back over to 4coder. Is there anything else I didn't go through? I didn't go through edit, H, and CBP. When does do not post to history get used? Right, whenever we're using the history system itself. That makes sense. Batch check, batch, create file. So let's see. Yeah, we want to think about what a batch edit will be like. Interesting. So batch edit's just a simple chain of edits at this point, huh? So an edit and a batch edit. What do we actually use edits for except to create batch edits, I wonder? Create an edit struct. Because we want to be able to record those edits into the history. Right, that's why there's a separate layer. Yeah. All right. Anyway, I think that's enough for today. Thanks again for coming to hang out. If you did, I'm getting excited about the 4coder Friday stuff. In addition to 4coder Friday, I've been working on this new bin dash project, which I'm going to be sending out a devlog to for everyone who's a supporter or a member or a premium member. We'll get a devlog today about the bin dash project and how that's going. If you didn't know, you can also go to on YouTube, if you go over to the Mr. Forth Unscripted channel, which is this one, you'll be able to see the pitch of the bin dash project that I posted about a week ago. And I'm really excited about that. It kind of connects with a lot of this 4coder stuff in the sense that I'm working on a core application with a customizable plugin interface. And it's going to include some of the wisdom that we're gaining from doing all of this what was I saying? So that I can apply better standards to the custom layers of the bin dash than I did for 4coder. Now, I know I started writing code in this little sorcerer namespace here today. I'm still not committing to writing a real new 4coder, but this is the best way I can think of to like keep track of my notes about like how things could have been better. Who knows, maybe it'll work as the inspiration for someone else's text editor, or maybe I will make a text editor out of it eventually. But with that, I thank you all for coming around and checking out the stream today, and I'll see you around the internet. Bye.